All right, today we're going to go over mother functions, and you probably have done this in Miss Fennell's class or in a previous math class. So I'm going to let you fill out the template, and then I'll point out some of the main features, but really this is a lot of review, okay? So just one thing to remember is that end behavior is as x goes to infinity, y goes, so this says as x goes to infinity, the y values go toward blank, okay? And then the same can be true about negative infinity. So this as x goes to infinity is reading to the right, and then as x goes to negative infinity would be reading to the left. Okay, so I want you guys to fill out the table graph and characteristics for a linear, quadratic, and cubic function. Linear, quadratic, and cubic. Okay. All right. We're going to take a break. And now here are the linear features. Oh, sorry, wrong way. Okay, so linear, it is also, whoa, my screen is going nuts. Here we go. Okay, major lag. So linear function is also called the identity function. Just move this over a little bit. Okay, it is, the reason why is when you plug in a value, you get out exactly the same value. It makes a straight line. The domain is all real numbers or negative infinity to infinity, and we use parentheses. Same with the range, negative infinity to infinity. This graph always increases, so we all the way from negative infinity to infinity, it's going to increase, or for all x values. We always read the intervals of increasing or decreasing using the x values of the graph. It's like a domain. The end behavior. Since it always increases, we start low. So as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity on the right, y goes, so as x goes to positive infinity, y goes to positive infinity. Okay. Quadratic, also called a square function or to the second degree. We have negative 2 squared would give me 4, so on and so forth. We look like a parabola. Our domain is negative infinity to infinity, and our range is 0 to infinity for the mother function, and 0 is included, so we're going to make sure we use a bracket. Okay. This graph increases and decreases, so from negative infinity to 0, so it's read left to right. So from negative infinity to 0, the graph decreases, and then from 0 to infinity, the graph increases. I've also seen in other books that sometimes they use a bracket at the 0. So it just depends on if the endpoint is included or not. I've seen different things, okay? So again, since the graph is symmetrical, the arms, as x goes to infinity and as x goes to negative infinity, they are both going to rise towards infinity. Okay? Cube function. This is x to the third power. Okay, so we're cubing each of the inputs. So negative 2 cubed is negative 2 times negative 2 times negative 2, which is going to give me a negative 8. Then so on and so forth. 0 cubed is 0. Our graph looks like this snaky thing. Okay, our domain is negative infinity to infinity, and our range is negative infinity to infinity. We increase the entire graph, so we go ahead and we say that the interval increase is from x equals negative infinity to x equals positive infinity. So it's reading left to the right. At what times are we increasing? Okay, because the graph is always increasing, on the left at negative infinity, the arm will drop to negative infinity, and on the right, the arm increases to negative infinity. Okay. Next up, you are going to do absolute value function, square root function, and cube root function, and rational function. So go ahead and work on those, and we'll go over our key features as well. Okay, so start with absolute value and radical or square root function. So absolute value is the absolute value of x. And what we're going to do is take the input, -2. The absolute value of -2 is +2. Okay. And what happens is that all the values that were going to be negative, unlike a linear graph, they become positive. So it makes this V-shaped graph. We have a domain of negative infinity to infinity and a range of 0 to infinity with 0 included. We decrease on the left, so starting from negative infinity to 0, so negative x equals negative infinity to x equals 0, the graph is decreasing. And then from 0 to infinity, the y values are also increasing. So we write them like so. Remember, these are mini domains. So when what x values is the graph decreasing and what x values is the graph increasing. The end behaviors, because it's a V shape and it decreases and then increases, both arms are going to go up, rise towards y is equal to infinity. Actually, it can't equal infinity, but it goes that way. Okay, square root function. I tried to take the square root of, I'm going to take the square root of easy numbers because they're easier to plot. So I'm going to take the square root of -4, and I know that I can't take a square root of a negative number, so it's undefined. Same with -1, it's undefined. So these are not part of our domain, but the first value I can take the square root of is a 0. So the square root of 0 is 0, the square root of 1 is 1, the square root of 2 is 2, and the square root of 9 is 3. See, easy numbers. So I went ahead and plotted it. It always looks like this swoopy thing that has an endpoint right here. Okay, has an endpoint in this blue. So the domain is restricted. I see a mistake. The domain starts at 0 with it included and then moves towards infinity. And then same with the range. We start at y equals 0 and then the values get larger and larger and larger. So bracket. We have this graph always increases starting from 0 to infinity with 0 included, or we can write 0 to infinity if the 0 is not included. Okay. In this case, the arm on the right, it goes towards infinity. So as x goes towards infinity, the y values are rising to infinity. And as x goes to negative infinity, we are undefined. But we have an endpoint. So I just added in as x goes to 0, the y value also goes towards 0 because there's an endpoint. Okay? So that's the end of the graph, but it's not really the towards infinity and negative infinity like we normally say. Okay? Cube root. The cube root of x, again, I took took perfect cubes because those are easier to graph. So I'm going to start with the cube root of -27 gives me -3. So -3 times -3 times -3 is going to give me -27. Then -8, 1, -1, 0, 1, 8, and 27. Those are all perfect cubes. Okay, so the cube root of 8 is 2. The cube root of 27 is 3. I went ahead and graphed that, and you get this little like wave type of graph. It's like a cube. It's the inverse of a cubic function. So it looks like a cube function that has been reflected over the line y equals x. Okay. We have a domain of negative infinity to infinity and a range of negative infinity to infinity. The arms on the end here, they will rise just very slowly. The x-intercept is 0, 0, and the y-intercept is 0, 0. This is an always increasing graph, so from negative infinity. So from x equals negative infinity to y is equal to infinity, the graph is increasing in y values. So because of that, on the left, as x goes to negative infinity, the arm is dropping to negative infinity, and as x goes to positive infinity, the y value is rising to infinity. All right, lastly, we have our rational function. We will deal with a lot of rational functions next chapter. So rational functions, I went ahead and plugged in a bunch of numbers and I got fractions, and then when I plug in 0, I get undefined. So I went ahead and graphed in an asymptote. Asymptotes are graphed with a dashed line because they are technically not included in the graph, but they are They are a key feature, so we like to graph them so we can see what's going on. We can write the domain as negative infinity to 0 or 0 to infinity, which means that the 0 is not included. You cannot equal 0. The same thing is true with the y values. You can see there is technically a horizontal asymptote as well, though we don't usually draw it in. Okay. Well, we can draw it in. Why not? See how well. Okay. At 0, y cannot equal 0. There is no x-intercept or y-intercept. It's okay for us not to have one, because the graph doesn't cross the y-axis or the x-axis. The graph is always decreasing. There's two arms from left to right. The graph is decreasing till we get to 0. So from negative infinity to 0, the graph decreases. Then we take a jump and the graph decreases again from 0, this time x equals 0, to infinity. As x goes to infinity, y is getting really close to 0, that asymptote, and as x goes to negative infinity, y is getting really close to that asymptote 0. Okay, so you should have all this written down. We should be getting pretty familiar with the way functions look. So if I ask you something like, what does an absolute value look like? You should be able to go like this, right? What is the domain of a rational function? What is the domain or what does a cube function look like? So on and so forth. So thank you very much. I hope you guys have a good day, and don't forget to watch the next video.